You'll have to excuse my sick voice today. I'm still not well, but I'm going to try and do a video for you. So we're going to look at total surface area today. So that's finding the outside of a shape, outside of a 3D shape, that is. So if I was going to make this shape out of paper or plastic or cardboard or whatever, how much would I need to actually create it? So what I'm going to look at is all the faces. So for a basic rectangular prism, you know that there are 6 faces. There's 2 front and back, 2 top and bottom, and 2 on the side. So I'm going to work them out separately. So I've got 3 different faces and there are 2 of each. So the first thing I'm going to do is work out the front. So the front is the same as the back. So my dimensions for the pink one are 3 by 6, right? So I've got 3 by 6 because it's 6 and 3, which gives me 18 meters squared. And there's 2 of them because I've got front and back. So that's going to give me 36 meters squared. All right, so now I'm going to do the side 2 panels. So I've got this side over here and this side over here. And this is 3 by 2. I've got the 2 written over here. So my green one is 3 by 2, which gives me 6 meters squared. And again, there are 2 of them. So I have 12 meters squared. Now I just have to do the last 2. So I've got the top and the bottom. I'll color these in blue. The top and the bottom. So this one is 6 by 2. So my blue ones are going to be 6 by 2, which gives me 12 meters squared. And again, there's 2 of them. So that gives me 24 meters squared. And then all I have to do is add all of these together. So I'm going to add my units column together. 6 plus 2 is 8, plus 4 is 12. Carry the 1, 3, 4, 5, 6, 7. 72 meters squared is the total surface area of this shape. All right, same thing over here. Now this is exactly the same, but not all my sides match this time, so I've got to be a lot more careful about working them out. So I'm going to start with the triangle because why not? So I'm going to start with the pink end. So I've got the front and the back, and they're going to be the same. So the triangle is half base height, remember? So the triangle is half times base times height. So I've got half times the base is 2 times the height is 4. Now just a reminder, for a triangle you must have the vertical height. It must be attached to a right angle. So always look for the vertical height attached to the right angle. So I have half times 2 times 4, so that's 8. It's 4. This is 8 and then half of that is 4. But I have 2 of them, don't I? Front and back, which brings me back to 8. So 8 meters squared are my 2 triangles. Now, these 3 rectangles around the side, the back, and underneath and then the back, they're all different sizes because I've got 3 different units of measurement. So I need to work them out separately. So the first thing I'm going to do is the bottom one. You can do them in any order you like. So this one is 2 by 7, which gives me 14 meters squared. And I'm just going to write that over here so that they're all in a row when I want them later. All right, so why don't I do the back one now? So the back panel is 4 by 7. So the back panel is 4 by 7, which gives me 28 meters squared. And then let's do the front one. I'm going to pick another color. Let's do red. So the front panel here, that's really messy to see, isn't it? Oh, I haven't given you one of the dimensions. That's very silly of me. I meant to write over here. This one, let's make it 5. Okay, now that's actually an impossible distance. If you know why, good for you. If you don't, just ignore it. You don't need to know why right now. So this big front panel is going to be 5 meters by 7 meters. So 5 by 7 gives me 35 meters squared. And then like I did before, I'm going to add all these together. So 8 plus 4 is 12, plus 8 is 20, 25. Whoops, I had trouble writing and speaking at the same time. And then there's nothing here. 1, 2, 3, 4, 5, 6, 7, 8. So 85 meters squared is my total surface area. All right, let's look at a more complicated shape. So we're going to look at oh my gosh, my brain has died, a trapezium. Wow, that was sad. Okay, we're going to look at a trapezium over here. So this has more faces. So what I'm going to do, well, first of all, I probably should have marked that these are the same length. That would have been smart of me. And I haven't written a top length because clearly I'm crazy today. All right, let's call it 4 meters. All right, so what I'm going to do is talk about my front face, But because we haven't done trapeziums yet, if you would like to look up a trapezium, you can certainly look up a trapezium. I might just tell you how to do that because even though we haven't covered them, it's easier just to use that formula. You can break this up into side triangles and a rectangle in the middle, but I think that's more work even though they're more familiar shapes. So let's look at a trapezium. Okay, so if this is h, the vertical height, I'm going to call this A and this B. So the area of a trapezium is half of A plus B times the height. So what we do is we add the top and the bottom together, right? Top and the bottom together, and then we halve it, right? Top and the bottom together and halve it, and then you just times it by h, which is the height of the shape. So let's try that to begin with. So I'm going to use this bit here. So blue is front and back. So for my blue one, I'm going to have half of A plus B, which is 4 plus 6. And then I'm going to times it by the height, which I said was 2. Now you might not be able to read my writing very well, but I promise it's meant to be a 2. Okay, so half of 4, so 4 plus 6 is 10, obviously. Let's make this 10. So half of 10 is 5, and 5 times 2 is 10. All right, so the area of my front is 10, but I have 2 of them, don't I? So I actually need to double it. So actually it's 20 centimeters squared. Now I wrote meters in the last one, I've got centimeters on this one. Pay attention to your unit of measurement. Okay, so now what I have is a whole bunch of different sides and they don't all match. So these two match, don't they? So this, pick a different color. So this back panel here matches this, or the two side panels, let's call them. So we have 2 of those. So this is just a 5 by 3, which gives us 15 centimeters squared, and there are 2 of those, so then 15 times 2 is 30 centimeters squared. Again, I'm going to write them in columns to make my life easier. Then I'm going to do the top one. So the top one I know is 5, so this is 5 by 4. So 5 times 4 is, well, let's write it over here, 20 centimeters squared, because there's only one of those. And then I'm going to pick my red pen again and do the base. So the base is 5 by 6, which is 30 centimeters squared. And then I just add all of them together again. I've got no units column, so 2 and 3 is 5. This is 100 centimeters squared. Well, that was a nice round number, wasn't it? That was a nice accident. So this looks like a complicated shape, but it's really just this new formula here that you need to look at. And if you can't remember how to use that, either go back and watch this bit again or come and ask me for some help. Okay, so again, you're just working out every available face and adding them together. So this question here is going to be an extension question. So if you would like to do this, then that's fine. This one takes a few more steps and it's a bit trickier, but let's go through how to do it. So hopefully we know that the area of a circle is pi r squared, right? So we're going to look at these two faces. So that means we have pi and r. So if I draw a circle over here, r is always halfway across, right? That's the radius, whereas the diameter is the whole way across. So if I've got the diameter, the radius is just going to be half of that. So I'm just going to square half of it. Now you need to square the 3, not these two things multiplied. So then I've got pi times 9, and so you need to use a calculator for this, please. Don't just use 3.14. That is an approximation and your rounding will sometimes be wrong. And so I would rather you press the pi button on your calculator and actually type this in so that your rounding is correct. Always give me 2 decimal places unless you're asked to do otherwise. So this is going to be 28.27 meters squared. But I've got 2 of them, don't I? So I actually need to double this. So let's double that, and I get 56.54. Okay, so these are these two. Now, the tricky bit comes in trying to find the curved bit. So if you think about a net, so this is what an unfolded cylinder would look like, right? The 2 sides are going to curl around. So what I really need to do is work out this bit, which is just a rectangle. Now the tricky bit is that I need to know this length here. I know this length here is 8 meters, right? I told you that it was 8 meters high, but I don't know this bit that's attached to the circle, this bit here. So what I need to do is work out the circumference of my circle first. So the circumference of a circle is 2 pi r. So then I'm just going to do 2 times pi times the radius, which is 3. So again, type that into your calculator, please. Whoops. So I'm going to get 18.85. If you didn't get that, it means you didn't round correctly. So it should be 18.85, and this is meters. So that's the length of this here. So then I'm going to take this number, 18.85, which is what this is here, 18.85, and times it by 8. And that's going to give me 150.8. So again, round correctly, you get 150.8, and then I've got to add this to it over here. So I have 150.8 plus 56.54. Okay, so I've lost my train of thought. Yeah, okay, so that's all you really have to do. So you're just going to add these things together, and then finally you will get these 2 circles plus the whole rounded bit, which is actually really just a big rectangle. So you should have 207, yep, 0.34. Cool. Okay, so this is the total surface area of your cylinder. Again, this one can be an extension question. If you think you can do this, then please do. Otherwise, I'm happy for you to work through the other examples that we did. All right, please let me know if you have any questions.